All right, Unit 3.2, function operations is what we're going to be looking at, and this first one is going to be arithmetic, or arithmetic, however you want to say it, operations. And so we're going to take two functions and we're going to perform arithmetic to it. And so let's kind of run through the list here. I know my colors are messed up. All right, so like for example, the first one here actually looks like this would be the equivalent of if someone came along and said, okay, I want to find f plus g of x. And so essentially what's happening here is they're saying, okay, that means we're going to take f of x and we're going to add it to g of x. The next one, when we put it together, would actually be like f minus g of x. And so that would be f of x minus g of x. And I'm going to go ahead and hit pause and kind of finish those off so you can sit there and just watch me. But just kind of keep in mind it's the same operation. Okay, so got those all written down for you. So basically, and this is what the operation is, adding, subtracting, multiplying, dividing. What you're going to see is what someone will ask you, or the computer asks you to say, okay, I want to take f plus g of x. Remember, that's called function notation, so f plus g of x, which essentially translates into, which means, like, you know, we're speaking Spanish here, and I said, hey, what does hello mean? Then this would be the hello in English, and this would be the hola in Spanish over here. So this is kind of like, what does it mean? Like, what does this guy right here mean as we move over? Well, it means that you're going to take the two of them and add them together. So let's take a look at that real quickly in one of these problems down here. So for example, if I said, okay, well, I want to start off here with example 1, and I want to take f plus g of x. Well, that means that I want to take the f of x plus the g of x. So I substitute those in. I literally right now take the f of x and I write that down below. So that means that the f of x becomes x squared minus 10. I take the g of x, right, which is 2 minus x, and put 2 minus x right there. Now, I'm going to put parentheses around this. Even though it's addition, I'm going to put parentheses right here because I want to keep that preservation, that concept, and maybe even put them right here for right now. Not because I'm going to multiply, but because I want to see that you know, if I think about this in terms of colors, this expression right here is the g of x, and this expression right here is the f of x. Now with addition, the parentheses aren't needed. They're only there, the parentheses are only there to help you make a visual separation right this moment. Because then the next step is that we combine like terms. Combine like terms. There's an R in there, you can't see it. So I go through here and I say I got an x squared. Are there any other x squareds? Nope. Cross them off. I've got a negative 10, and really let's go in terms of the variable. So I got a negative x. Are there any other negative x's? No. Or any other x's. So cross them off. I've got a negative 10 and a positive 2. I pull out my calculator. Negative 10, positive 2 is negative 8. So f plus g of x is equal to x squared minus x minus 8. All right, so let's take that process and let's go ahead and do subtraction. So I'm going to go ahead and hit pause for a minute so you have to watch me do all the parts, and you can kind of come back and watch me fill in. Okay, so there's my setup. I've got my f minus g of x. I plug in my formula. I substitute, I replace my f of x with my actual function, my g of x with my actual function. Now in this particular case, the minus sign, the parentheses do matter because what we have to keep in mind is that we're subtracting this 2 and we're subtracting the x. So when you have that negative sign right there, that means you're subtracting both of those. So what I've always suggested to my students is that you would think of this as being a negative 1 times 2. That would be a negative 2. And a negative times a negative times a negative is a positive x. And then once again, we're at the same step where we combine like terms. So we start on the left-hand side, x squared, got it. Positive x, got it. Negative 12, got it. So f minus g of x is this. Okay, I'm going to hit pause. We'll get started on the multiplication one. All right, so same situation here. The parentheses, as in the subtraction one, the parentheses make a huge difference because we see the parentheses create the separation of the two expressions. We've got the f of x expression, and we've got the g of x expression. And in this case here, we can see that to be able to solve this guy, we're going to have to FOIL. And so to simplify or to combine the like terms, or not combine like terms, but to simplify, we would FOIL this out. And so we start that process. So x squared times 2, that would be 2x squared. X squared times negative x would be negative x cubed. Negative 10 times positive 2 would be negative 20. And negative 10 times negative x would be positive 10x. Combine like terms, put it in order. So combine like terms, there are no like terms. Put it in order. Okay, well that means that the x cubed in descending order would come first. The x squared would come second. The 10x would come third, and the minus 20 would come fourth. So now what I want you to see here is this is an answer. My math lab is not going to take this answer because my math lab does not like having a negative on the front. That is not proper mathematical notation. And so at this point, what we need to think about is we need to get rid of that negative there. So one way to get rid of a negative on something is to multiply the whole thing by a negative. So essentially just take this whole entire thing and multiply it by a negative 1. And so essentially what you're doing is you're swapping out the sign. So my final solution for this guy would be a negative times a negative is a positive. A negative times a positive is a negative. And all of my signs are just changing. A negative times a positive is a negative. And a negative times a negative is a positive. So the catch here is that my math lab is going to keep you on track of having proper mathematical notation. And in proper mathematical notation, you can't have a negative on your leading coefficient. All right, so if you keep getting that one wrong, that's probably what's going on. So, all right, I'll stop it. We're going to do division with these two functions. All right, so here we are. And we'll take this one, and if you kind of noticed earlier, there was a little thing that said domain. Like, what is the domain? So, in this case right here, and there'll be different ones. There'll be different ones, you know, obviously the different polynomials that you're putting in. So f of x is going to be different, and g of x is going to be different. And so the main thing to think about here is can this be factored? You know, can you factor the top? So that way there would be a factor on top and a factor on the bottom that would cancel. Like for example, if this was x squared minus 4 over x minus 2. Right? This is an example. This is not the problem, okay? This is an example of side thought. So as a side thought here, you know, well, if I had these two guys right here, I could actually factor the top. And when I factored the top would become x plus 2, x minus 2 over x minus 2. And so at this point, we have an x minus 2 on the bottom, an x minus 2 on top. We could simplify that, and so our final problem would just be x plus 2. In this case right here, x squared minus 10 doesn't factor like x squared minus 4 because 10 is not a perfect square. So there's nothing on top that will cancel with the bottom, so that's our answer. Like that literally is your answer. So the answer to this problem, so f divided by g of x is literally just that. So let's bring on the conversation of domain. Now, remember that I want you to, as needed, to utilize your calculator to check your domain, but we've got to talk about with this whole idea is domain restrictions. And so with our domain, we talk about two main areas of that we want to pay attention to when we hear the word domain. And the first place is the denominator. So in this case here, we have a denominator. The other place is going to be a radical. Okay, so denominators and radicals are our two main places. So in this case, we take what's on the bottom and we say that cannot be equal to 0. Like, I can't let this be equal to 0. If this equals up being 0, then that's bad. I get an undefined function. We solve this guy. So we solve it for x. So I move the x over. And I find out that x cannot be equal to 2. So that means that my domain for this particular function right here, if we thought about it on a number line, just to kind of help you visualize it, so if I drew a quick little sketch of a number line real quick, and we said, okay, here's 2, any other number on this number line works. The only number that doesn't work, I can go this way forever, I can go that way forever, but the only number that doesn't work is 2. That's why it has an open circle on it. So that means that my domain would be from negative infinity to 2, open parentheses, unioned from 2 to infinity. All right, so that would be my domain for that guy. So let's go back and look at my domain for this guy. So in this case here, my domain would be all real numbers because there's no fraction, there's no radical. So my domain, I can plug in any number that I want. My domain would be negative infinity to positive infinity, which is known as all real numbers. MyMathLab wants you to put it into the interval notation there, the negative infinity to positive infinity. All right. Next, we go back here. We have an x squared, no radical, no denominator. So my domain is negative infinity to infinity. All right, last one, going back to the very beginning, and once again, the domain for this guy, no radical, no fraction, so in that case there, my domain would be negative infinity to infinity. All right, so that's our first little taste of arithmetic operations of functions with arithmetic, and so we're going to add a little bit to that, but that'll be the first video.